Hi everyone, this video is on exercise 9i question 3. So in this video I'm going to do part A, and we have a function f of x which is cos squared x minus 2 sine x, and we want to find any points of inflection. So if you want to find a point of inflection, we first need to find the second derivative of a function, and then we solve the equation f double dash x is equal to 0. And after that, what we can do is basically checking if each of the following points is the point of inflection, because a point is called a point of inflection where if the graph is, let's say, if the curve is concave, it changes and becomes convex, and vice versa. So now let's differentiate this, and then we will discuss the second part of that. Okay, so the first derivative is equal to cos squared x differentiates to, you can use the chain rule. So 2 is the power that comes down, and then the derivative of cos x is minus sine x. So I can just write minus 2 sine x, it's better, times then cos x the power minus 1. So 2 minus 1 is 1. And then minus 2 sine x differentiates to minus 2 cos x. Okay, we have this. We need to differentiate this one more time to get a second derivative. So we use the product rule to differentiate the first part, which is minus 2 sine x times cos x. So we write the first function times the derivative of the second function. So cos x differentiates to minus sine x. Then the derivative of first function, which is sine x differentiates to cos x. So we have minus 2 cos x times cos x. And minus 2 cos x, so cos x differentiates to minus sine x, and we have two negatives, so it becomes 2 sine x. And now we can simplify this, or at least factorize, because it's not in a very nice form. So f double dash x is equal to, the first term is 2 sine squared x. The second term is minus 2 cos squared x plus 2 sine x. Okay, we can take a factor of 2 to have sine squared x minus cos squared x plus 2 sine x. Now we need to have all the trigonometric terms in terms of one single term. For example, all of them should be sine or cos, so that we can solve the equation easily. The best way here is that writing cos squared x as I'm using the identity. Just to remind you, I'm going to write here that sine squared x plus cos squared x is 1. So here we have cos squared x, or we can just rearrange this such that we have minus cos squared x is equal to sine squared x minus 1. So we are going to use this and rewrite minus cos squared x as sine squared x minus 1. So f double dash x is 2 sine squared x plus sine squared x minus 1, and then another sine x, which is outside of the bracket. And also one thing that I should have done earlier, but for some reason I forgot to do so, was that when we wanted to factorize f double dash x, we also we could have take a factor of 2 sine x and have sine x inside the bracket, but for some reason I just didn't realize that. But yeah, now I'm going to include sine x in the factorization, which gives us even a nicer form. So 2 times, by the way, we have sine squared x plus sine squared x, which is 2 sine squared x. And if we include this term, we'll have a sine x term, and this minus 1 time. Okay, now this is in a very nice form, and we are at a position to solve f double dash x is equal to 0. So by doing so, we are going to have 2 times 2 sine squared x plus sine x minus 1 is equal to 0. So we can divide both sides by 2 and get rid of this 2, which is the coefficient outside the bracket. And we are going to have 2 sine squared x plus sine x minus 1 is equal to 0. Okay, now we can solve this equation, this trigonometric equation. And one way is by using a variable. So we can say let u be sine x, then we'll have 2u squared plus u minus 1 is equal to 0. And we can factorize this, so we can add the terms 2u minus u, because 2u minus u is still u, it doesn't change anything, and then factorize this. So take a factor of 2u, we are going to have u plus 1, and then also factorize these two terms separately with just a factor of minus 1. So it's going to be u plus 1. And then we are going to factorize then u plus 1. So we'll have u plus 1 and then 2u minus 1 is equal to 0, which means either u is minus 1 or u is half. And getting back to the main thing, because u was sine x. So this means either sine x is minus 1 or sine x is a half. And just note that the values of x are between 0 and 2 pi. This is going to be useful for solving the equation. So the only case that sine x can be minus 1 in that domain of x is when this is equal to 3 pi. When x is equal to 3 pi over 2. And for the other one, when sine x is equal to a half in that range, there are actually two values. So one value is when x is pi over 6, and the other value is when x is 5 pi over 6. Okay, a very common error is that when students get to this point, I mean when they solve the equation of the second derivative is equal to 0, and they get to this point, and then they find the solutions and they stop and they say, okay, these are the points of inflection, because the question was find any points of inflection. So they say these are the x coordinates of the points of inflection, and then they find the y coordinates and then move on. But there's a big problem, because there are two conditions that there must be satisfied in order for a point to be a point of inflection. So the first condition is when f double dash x is equal to 0 and you get some x coordinates. That's the first condition. But the second condition is also equally important, which is checking whether the curve changes sign just before and after each of these points. So that's crucial. All we have to do is basically, we can start by pi over 6. So let's analyze the behavior of pi over 6. So this means when x is pi over 6, let's see what happens. So first, let's find the f double dash x of pi over 6. So this is the value that we obviously expect to get 0. So we just substitute pi over 6 into the equation of f double dash x, which is written here. So we know that sine of pi over 6 is a half, but this is sine squared, so we get a quarter, and then 2 times a quarter is a half, so we have another half here, which is 1, and then 1 minus 1 is 0. Okay, so this is something that we expected, right? Because we expected to get 0 for the value of f double dash x, that's pi over 6. Okay, no problem. Now this is the important part, which is about checking. So we now check the value of f double dash x just before and after pi over 6. So like this. Let's see what we are going to get. So I'm just going to substitute these values into calculator, and for the answers we don't really need to state exactly, but you can if you like. But uh, if you try, you are going to get a very small positive number for this one, which is 0. Approximately 53. However, for this one we get a negative value, and this is exactly what we wanted, because for the point of inflection we wanted to get values with different signs to show that the curve is changing and it's going from concave to convex and vice versa. So we can therefore conclude that this is indeed a point of inflection. So actually we also need to its corresponding y coordinate, but this was the whole point of showing and proving that pi over 6 is the point of inflection. So we need to find f of 0 to find the y coordinate of this point. So yeah, the function is here. Let's substitute 0 and see what we get. So sine of 0 is just 0, and then cos of 0 is 1. 1 squared is 1. So we get 1. Basically, the point of inflection here is pi over 6, 1. That's the first one. Okay, the second one was when x is 5 pi over 6. Let's find out. So again, for the first step, we can check this all the time, but obviously this is going to be 0. The parts that are important are these. So the value of f double dash x just before and after this. So 5 pi over 6 minus 0.1. And this time, when we add 0.1, or actually after, we get a negative value, and for here we get a positive value. So in case you're curious, when we add 5 pi over 6 to 0.1, we'll get minus 0.53, but when we subtract, we are going to get positive 0.53. So again, this is exactly what we wanted, a change of sign. So this also means this is also a point of inflection. And now we can find its corresponding y coordinate. Okay, I just realized that, yeah, I made a mistake when I was finding the point of inflection of x is pi over 6, because we were supposed to substitute pi over 6 into the main function, but I somehow substituted 0. So yeah, sorry about that. F of pi over 6 is what we had to substitute. So yeah, let's work out that value. So let's keep that once I have shown that whether 3 pi over 2 is the point of inflection or not, then I will substitute each of these values to find the corresponding y coordinates. So yeah, just let's just write in this form for now, and then continue with that. And finally, the case where x is 3 pi over 2. So let's see whether this is point of inflection or not. So again, f double dash 3 pi over 2 is 0, obviously. But now the question is if 3 pi over 2 plus 0.1 and also minus 0.1 is going to satisfy the condition. And in fact, this time, if we substitute both of these values, we are going to get a negative value. And this is what we didn't want to get. And this means that this is not a point of inflection. And that's why we are always supposed to check the values, because we can't just, once we have solved the equation, just quickly move on and say, okay, these are the points of inflection. We need to check that by just checking the behavior just after and before each of these x values. Okay, now that we know 5 pi over 6 and pi over 6 are the points of inflection, or the x coordinates of the points of inflection, we can now find the corresponding y coordinates to finish this equation. So if we substitute pi over 6 into the function, we are going to get minus 1 over 4. So this is one of the points of inflection. And the other point is substituting 5 pi over 6, which is again minus 1 over 4. So this is the second point of inflection. Okay, so this question is now done. As you can see, it had lots of rooms for error, and I was also about to make error here. But there are also other parts, such as the calculation itself, and then also the fact that sometimes you can easily just get to this point and say, okay, these are the points of inflection, and you move on. All right, so that's it for this video. Thank you for watching.